Hello and welcome back to another IB Math Speedrun with me, Vince. In today's speedrun, we'll be going through Chapter 8.2, which is about how we use integrals and more calculus in kinematics. So let's jump right in. So, if you remember, I think 1 or 2 chapters ago, we discussed how the derivative of displacement is equal to velocity. Well, likewise, the integral of velocity will be equal to displacement. So we can use this, and the same holds true for acceleration. So the derivative of velocity with respect to time is equal to acceleration. So the integral of acceleration with respect to time is equal to velocity. So yeah. Now we can jump into some. Oh, there's one last thing we want to note. Remember that the actual distance, not the displacement, is equal to the absolute value of the velocity, since distance is a purely positive measure, and it also doesn't have a vector quantity. So yeah, just another thing to bear in mind. Now let's jump into some questions. Okay. So a particle travels with velocity. Please stop lagging. I'm actually gonna do question 2 instead. So for questions 2 to 6, you are given a velocity and a time interval. Find the times in the given interval when the particle first stops, next moves to the left, and finally moves to the right. And then the particle's displacement at the end of the time interval, and the total distance the particle travels in the time interval. Okay, so the first equation we're given is the velocity of the particle is equal to 3 cosine t, where 0 is less than t, less than or equal to t is less than or equal to 2 pi. Okay, so the first thing we need to find is the times in the given interval where the particle stops, and that we can find that simply when velocity is equal to 0. So yeah, we're given the velocity function. So this is simply when velocity equals 0. So 0 is equal to 3 cosine t. So t must be equal to pi over 2 or 3 pi over 2. So these are the 2 times where the particle is at rest. When the particle moves to the left, in other words, it has a negative velocity, this is simply when t pi over 2 is less than t is less than 3 pi over 2 for negative, and for positive, wherein it's moving to the right, this is when t is less than pi over 2 or t is greater than 3 pi over 2. So those are the sections. And then next we have to find a particle's displacement at the end of the interval. Well, we can simply get the limit of this between 0 and 2 pi of 3 cosine t dt. So this will be equal to 2 pi and 0 of 3 sine t. So this will be, I mean, it should be equal to 0 in theory. Sine 2 pi is 0 minus 0, so the total displacement should be 0. But the question is, how about the total distance traveled? And so to do that, we have to get the absolute value of 0 and 2 pi of 3 cosine t, the absolute value of 3 cosine t dt. And so, well, we already know for which values the particle will be moving forwards and which values the particle will be moving backwards. So we can utilize this to our advantage to split this integral into integral between 0 and pi over 2 of 3 cosine t plus the integral between pi over 2 and 3 pi over 2 of 3 cosine t dt plus the integral between 3 pi over 2 and 2 pi. Of 3 cosine t dt. So what we have here is, this is simply, we need to evaluate this for 3 different limits. So first 0 and pi over 2, and then pi over 2, and 3 pi over 2, and then 3 pi over 2, and 2 pi. This is not normally how you write that you're evaluating it for 3. Normally you would just write the absolute value function, but for me, this makes it easier to process. So what we get is first pi over 2 minus 0. This will be 3. 3 pi over 2 and pi over 2 is plus 6. Since this is negative 3, this is positive 3, and then here we have simply 3. So this should be equal to 3 plus 6 plus 3 is 12. Yep, that's correct, 12 meters. Okay, so it's in meters. So the next equation that we have is, we have this equation where the velocity function is equal to the square root of 2 minus t. And this will be between 0 is less than or equal to t is less than or equal to 2. So first we need to find for what values is the particle like not moving, or is it stopped. So 0 is equal to square root 2 minus t. So 0 is also equal to 2 minus t. So t equals 2. So at the very end of this motion, the particle will be at rest. It's going to be traveling positively when t is less than 2. But there are no values for where this will be moving negatively, since the square root function can never have negative values. So yeah. Find the particle's displacement at the end of the interval. Well, we can simply integrate this. So we have 0 and 2 of the square root of 2 minus t dt, which we can rewrite as 2 minus t to the power of 1/2. And so we know this is equal to limit between 2 and 0 of 2/3 negative 2/3 times 2 minus t to the 3/2. So this will be equal to really just 2/3 times 2 to the 3/2. So that's 2 square root 2. So this is equal to 4 square root 2 over 3 meters as the displacement. And the thing is, since we know that this is only traveling in a positive direction, and it only, well, it comes to rest once, so it technically has no turning points, this is actually also the distance. So in this case, displacement equals distance. Okay, on to the next one. We have the velocity function is equal to t over 1 plus t squared, where 0 is less than or equal to t is less than or equal to 3. So when is this at 0? This particle is at rest when t equals 0. And for all values above 0, the particle will be moving to the right. it won't move to the left at all. Okay? And technically we have to say it's less than or equal to 3. Anyways, find the total displacement. So between 3 and 0 of t over 1 plus t squared dt. This will be equal to, well, we notice that the derivative here of 1 plus t squared is equal to 2t. So this is simply equal to 3 and 0 of 1/2 ln 1 plus t squared. So we get that this is equal to 1/2 ln 10 minus 1/2 ln 1, which is 0. So it's just 1/2 ln 10. Yeah, so the distance should be equal to the displacement, since we only have positive, or the particle is only traveling to the right or at rest. So this should both be the displacement and the distance traveled. Finally, last question, question 8. A particle moves along the x-axis so that its initial position is 8 centimeters right of the origin. Given that the integral of the sum times t and 0 of v of t dt is equal to -2 of the integral between t to the 1 and t to the 2 of the same velocity function, and that's equal to 16 of the integral between t to the 2, this t2, and t3 of vt dt is equal to -7. What do we have to find here? So we need to find the particle displacement between 0 and t1, find the total distance traveled between t1 and t2, and finally find the position of the particle at times t1, t2, and t3. Okay, between 0 and t1, well, we know that the integral between 0 and t1 of this function is equal to -7. So the particle's displacement should simply be -7. Or do they want us to give it relative to the origin? Oh, there's a semicolon. Oh, sorry. I've just realized there's a semicolon, so this separates the actual function. So this makes a lot more sense now. I thought it was -2 times the integral. Anyways, in this case, 8 minus 2 is 6, so the new displacement is 6. Total distance traveled between t1 and t2, well, that's equal to, because we start at 6, so this would be 22. So the position of the particles at these times would be 6, 22, and then what's 22 minus 7? That is 15, I believe. So these are the 3 answers. So yeah, that was pretty easy. That was all for the speed run, and I hope to see you in the next one. See you then.